Hello math lovers, welcome to the channel. In this video I have a very nice problem in front of you. The problem is a mix of geometry and Venn diagram. So let's dive into the question. The question says that three circles of equal radii overlap one another. The center of each circle lies on the circumference of the other two circles. Find the ratio between the area of the region common to all the three circles and the area of the region common to exactly two circles. So let's understand the question first. So here we have a diagram. So you can see that there are three circles in front of us which overlap one another, and the radii of all the three circles is the same. So focus on this circle. The center of this circle is E, and E falls on the circumference of the other two circles. Similarly, the center of this circle is D, and D also falls on the circumference of the other two circles, this and this. Likewise, F is the same as D and E. Now come to our question. The question requires us to find out the ratio between the area of the region common to all the three circles and the area of the region common to exactly two circles. So what is the area of the region common to all three circles? So that area is the area enclosed by these three boundaries. That means this area. So if you are standing in this area, then you are standing in this circle, you are also standing in this circle, and you are also standing in this circle. That means you are standing in the area that is common to all the three circles. The denominator of this question says that we are looking for the area of the region common to exactly two circles. So what is that area? That area is the sum of this area, and this area. So if you are standing in this area, then you are standing in the region that is common to this circle and this circle, but not this circle. Similarly, if you are standing in this area, then you are standing in the region that is common to this circle and this circle, but not this circle. Likewise, if you are standing in this area, then you are standing in the area that is a common region for this circle and this circle, but not this circle. We need to find out a ratio between this area and the sum of this, and this area. So friends, in order to find out the ratio, we have to make some constructions. So what are the constructions that we make? So here we join the center of all the three circles and an equilateral triangle is formed, and then we join D to A and E to A. Similarly, we join D to B and F to B, and we join F to C and E to C. So we see that four alike equilateral triangle ADE, triangle DBF, triangle EFC, and triangle DEF are constructed in the common region, or the region that is shared by these circles. So they have equal area. So let's say that the area of these equilateral triangle is X. So the area of this, and this triangles are X. So we also see that there is a shaded region. So this much is the common area for all the three circles. We make an equilateral triangle here, but we also find that some region is left. So we shade this region. So there are 9 such identical segments of area in the common region. So 1, 2, 3, 4, 5, 6, 7, 8, 9 regions. So let's say that their area is Y each. One thing to note is that this equilateral triangle has its full area, but the other three triangles do not have full areas. This is because you can see that this shaded region is inside this triangle, whereas you do not see any shaded region inside this triangle. This triangle has also a shaded region inside this triangle, whereas this triangle also has this shaded region inside this triangle. So this triangle has a full area X, whereas this triangle is X minus Y, whereas this triangle is also X minus Y, and this triangle is also X minus Y. Now the area common to exactly three circles, that is this area total, is X plus 3Y, 1, 2, 3Y, whereas the area common to at least two circles. What do you mean by the area common to at least two circles? That means the area that is common to two circles and also three circles. It comes out to be the area that is inside these boundaries, means this complete total area. We can see that there are 9 shaded regions, so it has to be 9y, but there are also 3 such regions that are inside this triangle. So 9y minus 3y will be 6y, so we have 6y here, whereas there are 4x, that is 4 equilateral triangles, 1 2 3 4, so we have 4x. So this whole area, common area, is 4x plus 6y. So the area common to exactly two circles, so this area and this area, so that will come out as 3x plus 3y. So you can see that there are 6 shaded regions, 1 2 3 4 5 6, but there are 3 shaded regions which overlap this triangle. So 6y minus 3y will be 3y, whereas there are 3 triangles in exactly 2 circles, that is 1 2 3, so we write 3x plus 3y. So our required ratio will be the region common to all 3 circles, that means x plus 3y, the area common to exactly 2 circles, that is 3x plus 3y. But our required ratio is in expression form, so we need to simplify it further. So to simplify it further, we need to find out the relationship between x and y. So in order to do that, we need to first find out the area of equilateral triangle, that is, we need to find out the value of x. So the area of equilateral triangle formula will be root 3 over 4 times a square, where a is the side of the equilateral triangle. So here we can take any of these equilateral triangles. Say we take this triangle, so the side is suppose db, but we see that db is actually a radius of this circle, because d is the center and this b is a point on the circumference, so db is a radius. So we can keep root 3 over 4 r square, so that will come out as 0.43 r square. Then we'll find out the area of this segment y, that means this shaded region. So how can we find out the area of y? So in order to find out the area of y, we can take this full area, means this area which contains this shaded region and the area which contains this equilateral triangle, that is x. So we can actually subtract this full area by this triangle, and what is left is this shaded area. In order to do that, first we'll need to find out the area of this full circle. So the area of the full circle will be pi r square, so we keep pi r square. Then we need to find out the ratio of this area to the area of the full circle. So you can see that this is an angle of an equilateral triangle, so it is 60 degree. So we can keep 60 degree, for example, like this, whereas the full circle is 360 degree. So if we find out the ratio, then it is 1/6. That means this area which contains this and this shaded region also is actually 1/6 of the area of the circle. So we can keep 6 here. So we get from this much part, we get the area of this sector. Then after we can subtract the area of this triangle. So we already know the area of this triangle is root 3 over 4 r square. So if we simplify this, we get 0.09 r square. Then we find out the ratio of x is to y. So the ratio of x is to y will be approximately 4.78. So we can say that x is approximately equal to 4.78 times y. Now we can substitute the value of x, that is x is approximately equal to 4.78 y in our required ratio. So x plus 3y over 3x plus 3y. So in place of x we can keep 4.78y, and in place of this denominator x also we can keep 4.78y. So when we simplify this, we get 0.45. So therefore our required ratio between the area of the region common to all the 3 circles and the area of the region common to exactly 2 circles is 0.45. Answer. And friends, do not forget to subscribe the channel because I will be bringing more such beautiful maths videos in the days to come. Thank you for your time, and I will appreciate and feel motivated if you like this video. Thank you.